All right, we are live. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. I think we're live on both sides. Yep, looks like we're good. I've had to change streaming setups. If you didn't realize that or hear about it on Twitter, I'll get into that in a minute. Luna Moon, you are indeed first. Welcome. Maget's good to see you as well. All right, so we are going to pick up where we left off last stream, but I'm going to touch on that in just a minute too. Before we do any of that, though, I do want to take just a quick second and thank the supporters of the channel, beginning with our elite partner, Javier Alazaron, followed by our partners, Gaboli's Inc. and Matt Oscard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by all of the supporters you see here listed on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover the cost of running this channel. You know, things like software licenses, hosting fees, hardware, which we're going to get into for a second. But yeah, your support is greatly appreciated, so thank you very much for that. And of course, I would be remiss if I didn't mention a big thank you to everybody here who is joining us either live on the YouTube or the Twitch side, or if you're just catching the VOD after the fact. You guys, the viewers, are the reason this channel happened, and the reason this project exists. So thank you guys very much for being here and following along, and interacting and all that good stuff. I appreciate each and every one of you guys, so thank you very much for that. Okay. So, for the astute viewers among you, you might notice that I'm on a different setup here. You see like EXE up here and like EXEs down here. Yes, I am back on Windows for the time being. Reason being, the SSD that held my Twitch subscription, that held my Arch install and all the data on it, completely gone, dead in the water. And there's not really any way I can recover anything off it, unfortunately. So I wasn't really expecting that. But Pierre JRT, thank you so much for the Prime. I appreciate that. Thank you very much. Yes, we definitely appreciate our Brazilian viewers. I know there's quite a few of you guys out there. So thank you so much for the Prime. I really appreciate that. 2 months. Thank you. I think my notifications are broken, which is kind of the theme of this week, to be honest. So essentially what happened was I went to go prepare for stream last night, and I went to go boot up my machine, and my machine just basically said, there's no SSD installed, and where your Linux install was. It's like I went into the BIOS, didn't even find it. Tried moving it around to different slots on the motherboard. Didn't matter. The ones that, the SSDs that were working, they're M.2, right? So they're bolted directly to the motherboard. Those ones that were working showed up in whatever slot I plugged them into. The one that has my Linux install on it, along with all my user data, unfortunately, that one would not show no matter which slot I put it in on the motherboard. So I know it's not the motherboard, it's definitely the SSD itself. No warning, unfortunately. Yeah, I've had that happen once or twice before in the past where it didn't show up. And I didn't really think much of it. I could just power cycle the machine and it showed back up. Yesterday I did that about 30 times and it didn't. So it's dead for sure. So there's not really, unfortunately, a way for me to get any data off of that, and thus the OS and all my settings and all that stuff are gone. So that's the bad news, right? The good news is I did have I backed up a lot of my data probably about a week or so ago. So I'm only about a week in terms of data loss there, which is not terrible. It's not ideal. But unfortunately, I had done a bunch of work over the weekend. I did about probably 6 or 8 hours worth of work on the project to try and drive it forward over the weekend. And I committed it, but apparently didn't push it. So that stuff's all gone too. So we're actually going to be going through that tonight and rewriting it. Fun. So there's that. And then I just noticed now that my Streamlabs is not working on the Twitch side. So that's kind of in theme with this week, to be completely honest. Let me just check something real quick. Because, of course, in my tests before, it was fine. Oh, there's an update. I'm not going to do that now. Bear with me just 1 second here. I just want to... I want to verify that this is hooked up how it should be. It should be fine. I'm probably going to have to go to the account itself. So I've noticed the bot isn't working on that side at all, and neither are the notifications, unfortunately. So, like I said, kind of fits, right? Bear with me just 1 second. Maybe all I have to do is refresh it. All right, so hopefully I think that might have done it. Let me see. I'm just going to test a message really quickly. I'm going to run the starting message just to make sure it works. See if that works. It should show up on both sides. And it's still not showing. All right, I'll debug it offline. I'm not going to spend too much time on that. So I'm not surprised there's a couple hiccups, right? I changed setups here, so it is what it is. Yeah, it's definitely not good, Magets. So that's the thing about SSDs, right? Is when they decide they're going to die, they just kind of die. There's no warning. There's no getting the data off of it. As far as I know, it's just dead. It's actually still plugged in, but it's dead. It can't be accessed, right? As far as the BIOS knows, it's not even there. That's the one thing I miss about spinning platter disks, right? Is the fact that you can at least, in a lot of cases, recover the data off of them. Chill Crunch, how's it going? Good to see you. Welcome. Singy, good to see you over there on the YouTube side as well. Ronak, Paul, good to see you as well. I hope I pronounced that right. You inspired me to try and code live. Was nervous about it, but I wanted to do it for a while now. That's awesome. Are you doing that on YouTube or on Twitch? Because I will toss you a follow. Let me know. And I'll try to tune in if you happen to be streaming when I'm free. I nailed it. All right, awesome. It's very hit or miss for me. Okay, cool. But yeah, let me know if you're streaming on YouTube or Twitch, and I'll toss you a follow. I want SSDs that just use magnetic plates that don't spin. Yeah, that'd be nice, right? Yeah, so anyways, I've got to source a new SSD, which I could order it online, right? But there's actually a Micro Center that's about an hour and a half away from me. And so I'd rather go there and get it in person, because I can actually save a little bit of money that way instead of ordering it online, and I can get what I actually want. So I'm probably going to go ahead and do that, but it's going to be a while before I do that. So to bring all this back into full circle, I am using my backup Windows setup, right? So unfortunately, I'm not on Arch. I do need to get Arch installed onto my other machine, and I might do that because that's got drives that work. So I might actually get that set up, and maybe we'll stream from that. In the meantime, we'll have to see. But I got this set up back up and running, and so this is what we're going to stream off of for the foreseeable future until I at least am able to source that new hardware, get the new OS up and installed, and get all my settings back and all that good stuff. So that is kind of the big update that I've wanted to kind of go over before we jump into the code. All right. Oh, you know what? Yeah, you're right. It did switch that, didn't it? Sorry about that, chaps. Here we go. All right, I wasn't really doing anything on screen anyways, but yeah, thanks for calling that out. I appreciate that. And my Stream Deck just died. Oh, man. When it rains, it pours, huh? Yeah, my Stream Deck just stopped working. Awesome. Okay. Well, I'm going to have to do without that, I guess, the rest of the stream. Oh, wait, there it is. There it is. Ah, okay, it had a software up. I guess it needed the software update. All right, let me try one more thing on this. I'm just going to try pushing through one more message. Okay. Now it works. All right, we're good. Okay. That's one of the reasons I started the stream a little bit early tonight, because I knew that there were going to be some technical issues and some bumps I had to get over. So, with all that out of the way, the good news with all this SSD stuff that happened is I did not lose anything that we did last stream. That is actually where we're leaving off. So even though I did a bunch of work over the weekend that I lost, none of that work that I lost was from the last stream. I did check that stuff in and push it up to get. So all of the work that we're going to take a look at on this stream is stuff that I've already kind of done before. And I have to essentially redo. So we're going to see how far we can get and go from there. So essentially what we're doing is we are in the application prepare frame, and we're in the stage where we need to actually fill out all of those structures that the bespoke renderer is expecting, and we need to fill all those in with data and then actually pass them through to the renderer, right? And we kind of had put on the last stream some to-dos with all of the different passes, right? So I started actually filling out the shadow data pass stuff here. And so if I go down here, we still have the forward pass, world debug pass, editor gizmo pass to do. And so we'll take a look at those tonight as soon as we finish up this shadow pass stuff. So essentially what this is further down from this, we actually have this to do here with a bunch of hacks and stuff like this. Everything below this line essentially is going to disappear. And essentially what we have here is we have our old render graph code. And so essentially what we need to do is we need to take this and translate that into our new bespoke renderer code, which in some cases it's going to drop right in. And in other cases, we have a little bit more work to do, right? So this one here is the standard UI. This one here is the forward pass, which is going to be probably the most amount of work out of all of them. And then below that, we have the shadow pass, which I've already stripped out the code out of that. And then we have the debug pass, of course. And then we have the editor gizmo after that. And that is essentially what we're going to work our way through tonight. And we're going to translate all of that that logic from the render graph stuff to the bespoke renderer, setting up all of those structures and whatnot. So I have done a little bit, I did a little bit offline last night, because by the time I got this set up and running, it was probably about 9:30 my time. Or no, it was probably about 10:30 my time. By the time I had this up and running, so, I was well into the normal streaming time. So I just decided to kind of bang out some of the code. So the way that this works is before we had, I think we already added this last stream, where we have a pointer to our renderer. I took a pointer to the frame allocator, because a lot of the operations that we're going to want to do here, we're going to want to use the frame allocator for. So as a refresher, the frame allocator is lightning fast because it works in a linear fashion, right? So it's an allocator that we use for per frame allocations. So any arrays that we need to set up or any sort of dynamic allocations we need that have to happen every single frame, we try to avoid those wherever we can, but wherever we do need them, we want to use the frame allocator for that. And that's because all the frame allocator does internally is it essentially has its own bank of memory, and it essentially just moves a pointer along that bank of memory every time you allocate from it. And so there's very little, almost no overhead from that allocator. It doesn't have to maintain a free list or any of that stuff. And then at the end of every single frame, after that's already been processed, it gets wiped out and reused. And so that is what our frame allocator is going to be used for. We're going to try and use that for all of our allocations within the context of a frame. And so we already had these here before: the current zone, current scene, and current viewport. Those pointers already existed before. We took a pointer to our render data. So that's just stored in our app state as frame render data. We zero that out at the beginning of every frame just to make sure that is wiped out. And everything in terms of data that we're going to fill out in this is going to use that frame allocator. And so that just makes our allocations much faster and reduces the overhead of all of our allocations in the context of a frame to keep things quick. So the next part of this is we essentially have a check that runs where we only need to run certain of these passes if we actually have a current scene and that current scene is actually loaded. If these aren't the case, we can actually skip a lot of work. So essentially, this deals with things like doing a little bit of preliminary setup in terms of calculating some of the cascade, shadow cascade data, getting a pointer to the directional light, things like that, calculating the cascade splits, the projection matrices. We don't need to do all that work if we don't have a scene that's ready to go, right? The shadow pass itself, that entire shadow pass, does not need to be run, obviously, if we don't have a scene that's up and running. So that is included in here. The forward pass, so the forward rendering pass, does not need to be executed if we don't have a scene. Same is true for the world debug pass and the editor gizmo pass. Both of these don't need to run if we don't have a scene, right? Because what are we rendering otherwise? And then we are only going to render the world debug pass and the editor gizmo pass if we are in debug mode. If we're not in debug mode, we should not be doing those things. Okay. And then finally, once we pass the loaded level check, that is where our standard UI will live, right? And so that always gets rendered no matter what, because we're always going to have UI on the screen no matter what we're doing. And then essentially everything below that is going to be the logic that we're getting rid of, right? So we're basically hoisting the logic from down here up to the top and dealing with it one thing at a time, right? So that's kind of the overview of what we are doing, right? And I've already worked some of this out. And like I said, I've actually coded some of this before, although now all that's gone. So some of it's up here in memory, but some of it we're going to have to design on the fly. All right. I hope all that makes sense. Baldy Locks, how's it going? Good to see you. Appreciate the high emote there. I need to come up with some emotes. So if you guys have any ideas for emotes, please let me know. I need to add some more, actually. Okay, so let's talk about a little bit about what the Shadow Pass needs. So the Shadow Pass obviously needs all this other stuff that we've calculated up here, right? So the first thing we do is we grab a pointer to the Shadow Cascade data. And so just to kind of recap what that data structure looks like, so we have our render data structure here. We have, and this has changed a little bit since the last stream. So we now have a Shadow Pass render data. structure, right? And we'll go into that in just a second. So we have one structure for the shadow data, one structure for the forward data, one structure for the world debug, one structure for the editor gizmo data, and then one for the standard UI data. So this has changed in that we obviously this structure is new since the last stream. So this entire structure represents the entire shadow pass. Before, what we had was essentially these cascades, and then we also had meshes within those cascades. But that doesn't make a whole lot of sense because of the way that the shadow pass works. So what we have now is we actually have a list of cascade render data, which all that's contained in each one of those is a view projection matrix for now. I suspect at some point we'll probably be expanding this, but for now, that's all there is in there. That's the only thing that differs between cascade passes, right? And then we have a list of opaque geometries, and then we have transparent materials, or transparent geometries by material, right? And this should probably actually say, let me see. Yeah, this should probably be renamed. Let's rename this to, because it's not just meshes, right? It's actually technically geometries. So what this is we essentially take we loop through all of the geometries that qualify to be drawn in the shadow pass, right? And those geometries are used for each of the cascades. And the reason that we use all of the geometries in that same list of all the geometries for the cascades is because we do need to handle shadows of objects that are perhaps not within the view of the camera, but maybe behind it or something. And our shadow cascade pass takes care of that, right? And so we essentially use the same list of geometries no matter what. That's why we have one list of opaque and one list of transparent. And the reason that they're separated is because all opaque geometries can actually use just a solid white texture when calculating what whether the shadow should be on or off. But if we have a transparent material, we then want to get the transparency from the texture, specifically the diffuse texture, or the albedo, right? The base color. We want to sample that texture so that we get sort of holes in our shadows. So think the leaves of a tree, right, is the best example for that. So for each one of those, for each one that's transparent, we need to separate that or all geometries that use that material into their own category. So we have this Illumina material data that we talked about, or Illumina material render data that we talked about in the last stream. That hasn't changed. It's just sort of the organization of it, right? So we have a flat list of everything that is an opaque, because that can all be classified under the same sort of material or group in the shader. But we do have to separate out materials that are transparent. We have to separate those out by material, right? So that's that. And then we have the train geometry data, which just lives at this level and is used in all cascades. So that is essentially what that is, and that is the bulk of the change in terms of structure. All right, so what this does, or what the original thing does, is it would essentially collect a list of these geometries and feed them to the shadow render graph node, which we no longer have. So what that would do internally is it would actually perform the separation of the opaque and transparent geometries, right? Materials, rather. And so the renderer already assumes those things have been split up. So we actually need to do that here. And so I've got a little bit of notes in here on how we're going to tackle this, right? So the first thing that we do is we query the scene. according to, where the directional light is and all that stuff, right? So we perform the query of the scene. This hasn't changed yet. And that provides us a list of geometries, right? So that list of geometries, we then need to say, well, hey, do we have any first off? Because if we don't really have much of anything to fill out, right? If we do, we go ahead and we set up a opaque geometries array and a material or a transparent geometries by material array. And so we allocate those using the allocator, right? That frame allocator that we talked about. That guy, right? And they're both set up that way. So again, the advantage there is speed, right? Because we're going to be setting this up every time. We don't want to have to allocate it and then free it, set up and tear down every single time. So we go ahead and set that up, and then we go ahead and we iterate the geometries to go ahead and split that into the appropriate group, right? So the problem with this is we're going to actually have to do this in a few different parts of the code. And that's why I have a to-do here, that this really should be handled by the scene, but we're not handling the scene rewrite yet. So we're just going to do it for here. We're going to do it here for now. And then when we refactor the scene, we'll go ahead and handle it at that level. Let me see. Emote tractor. Yeah, you're not wrong about that one. Didn't I should have a refactor tractor remote if I don't already. I don't remember if I do though. I don't think I actually have a refactor tractor remote, or emote rather. I don't. I should have a refactor tractor one. Yep. You know what? Let me take a note of that, because that's a good idea. Yeah, that's a good idea. I should add that one. Thank you for that suggestion. Let's see. Where are you from? First time chatter, Julius, by the way. Welcome. I am from the US. Specifically, I mean, I used to live in Florida, but I've since moved from there. I live in South Carolina now, if that is what you're looking for. All right. So what we are going to do is we loop through the geometries. And the first thing we do is we ask, does this material have transparency? If it doesn't, our operation is simple. We essentially create a new geometry render data and jam that into the opaque geometries, and we're done, right? If it does have transparency, then we have a little bit more work to do. So we have this concept of a current material up here, which is a pointer to a material render data structure, and we zero that out. And so essentially what we have to do here is, if it's transparent, we need to say, is this the same material that our current material is? And if so, we can just add it to that collection. If not, we need to create a new group of that, add it to that group's array, and make sure that that group gets pushed into the transparent geometries by material, right? And so that's the bit that we're going to have to do here. And so, obviously we have this check if different, if not file into different group, if different, create a new group and file into it, right? Let's see. All right. So we're going to do that now. So let's remove the to-do. So we're going to do that by, we're going to say if, not gdata, or gdata, wait a minute, not gdata, sorry. current material, right? So if we have no current material, or, oops, keep hitting the wrong keys, or the current material, base material, is not equal to gdata material, which is the base material, right? So this is going to be different, or otherwise this is going to be the same, right? And so in this case, let me see, this should be base material. We should compare the handle indices of these, actually. Right? Okay. Move this out of the way a little bit. All right, so let's handle the sort of simpler path first. So I'm just going to take this, and I'm going to copy pasta it here. Yes, I know, don't repeat yourself, right? But we're just trying to get it to work for now, and then we'll fine tune it later. We're going to be refactoring this logic when we hit the scene code anyway. So we want a new data. We set up all the things. This should actually be largely the same. The only difference is going to be the addition of one more field. So that's going to be material instance, which I think that's just the actual handle itself. So we're going to say material instance equals, and we'll do g data material instance, right? And that is going to be all we should have to do. And then what we'll do is, instead of pushing to opaque geometries, we're going to push to current material geometries, right? We're going to push the new data to that. And then we're going to say current material geometry count ++. Now, D-arrays do actually handle count on their own, but I think there's a high chance that we're not going to be using D-arrays in perpetuity for this. So I'm going to treat this as if we're not using that, and maintain the count separately. That way, if we ever change it, it doesn't change beyond us having to not use a D-array here, right? Let's see. Any plans to move to NVRHI in the future? Nope, definitely not. We are about doing things as low level as possible here, and doing things from scratch, right? Not only as a learning exercise, but for elimination of dependencies and not having to rely on external libraries for things, especially in the runtime, because that's can generally lead to things breaking and things like that. But we are sort of doing this from scratch. So me using NVRHI would not fit into the way that we're doing this project very well. So NVRHI is NVIDIA. I think RHI is Render Hardware Interface. I think. I'm bad with acronyms. It's essentially a library that NVIDIA wrote to sort of abstract Vulkan. It's written by NVIDIA. Supposedly it works with, all GPUs, right? But it abstracts a lot of the low level stuff from having to directly use a lot of parts of Vulkan and things like that. Think of it as it's almost kind of an equivalent of, I don't want to say something like it's not like a rendering library on its own, but it kind of abstracts rendering APIs in such a way where you're not dealing with the rendering API itself, you're sort of dealing with their API, and it's sort of just an abstraction layer on top of that. Can some material update during the frame and need a descriptor update? So when you say update, I mean, yeah, some of our materials have per frame updates. So yes. And we handle that. All of our Vulkan backend handles all of that automatically for us. The concept of a descriptor is not known to the rest of the engine. Okay. So I'm actually thinking, actually, this code can be moved outside the else. And the else can disappear. Reason being, we only really need to handle different stuff happening in here, right? So if the material is different or one's not been selected yet, then what we need to do is we need to create that material group, set up its arrays, etc., and then set current material to that. That can all happen before this, so we actually can just reuse this block. So the first thing that we're going to have to do is we're going to have to actually set up a Illumina material render data, and we're going to call this new mat RD, and we're going to set that equal to a new structure, right? So we're going to say geometry counts is obviously going to be starting off at 0. Geometries. So this is going to be another D-array create, right? Illumina geometry render data. So this is going to be equals D-array create with allocator. And its type is going to be Illumina material render data. And we want to use the frame allocator for that. And then the base material is actually going to be G data material, right? Which is the base material for that, right? So we have that. And then what we can actually do is we can say, how do I want to do this? I guess we could say, let's do U32 count equals the array length. And we're going to say, render data, shadow data, transparent geometries by material, right? We're going to get the current count of that. Then we'll do a D-array push into render data, shadow data, transparent geometries by material. And we're going to push in new mat RD. And then we're going to set current material to the address of render data, shadow data, transparent geometries by material, sub count, right? And that will give us everything that we need here. Let's see. Oh, semicolon doesn't belong there. Okay. All right. So let's actually just move. Oops. Let's actually just move. Let's move this down here. Right. All right, so we'll want to set as current. And then here we're actually going to say push into current materials geometry array. All right, that should get us everything that we need as far as that. Okay. All right. I think that is actually... that's everything we should need for that, right? So we do want to leave this to do here because we eventually are going to be moving this code. All right, so that's going to get us all of the geometry translated from this geometries to either opaque geometries or transparent geometries, right? And then, of course, at the end, we go ahead and we take a count, right? Let me see. One more thing. We do take a count of these. We take a count of those. We do current material geometry count. I think all of our counts are going to be good. Okay. Yep. We should be good to go. All right, so what that means is we can actually get rid of this step entirely, right? We don't need the render graph code for that anymore. Now, the next thing that we need to do is loop through the terrain geometries and perform a similar step, although we don't have to do all of this sorting of materials based on transparency and all that stuff. We don't actually care about the materials in this part of the pass because terrains can never be transparent. Terrains are always opaque. Right, so we're going to treat them as such, and we're not going to sample from the terrain material. So essentially, what we can do is I'm actually going to... let's actually just write this. I was going to copy pasta some of it, but I think we can just write it, right? So right here below the drawn mesh count, which we still want to keep, we're going to say if terrain geometry count, right? And then we're going to go through all of those terrain geometries. So for U32, guess we'll say TG equals 0, I is less, or TG is less than terrain geometry count plus TG. And essentially what we're going to do is we're going to create our render data for each one of those things. Before we do this, though, we actually need to instantiate our arrays, right? So we need to do render data, shadow data, and then we need to do HM for height map terrain. So this is going to be height map terrain chunk count. So a terrain chunk is essentially the same as a terrain geometry, right? We're going to when we refactor this API, we're going to clean that up a little bit. But essentially, the terrain chunk count is equal to terrain geometry count, right? Render data, shadow data, HM, terrain chunks, right? And that is an array of chunk render data, terrain chunk render data, right? It's going to be D-array. Actually, we don't even need a D-array for this one. We can actually just straight up see... wait a minute. No, we should do frame allocator, allocate, size of, and we want HM terrain chunk render data times terrain geometry count, right? And so that's going to give us that render data, shadow data, HM, material instance. This is going to wind up being, so this is a little bit, let me think about this. Do we actually need the material instance at this point? What would we need the material instance for in the shadow data? I actually can't think of anything. So let's actually go to definition. I'm going to delete that because I don't think we need it. The terrain model is a little bit of a different scenario, though. So what we're going to do here is I'm going to say terrain model is equal to met for identity. And I'm going to put to do on this. Use terrain model transform. Because we don't actually have that here yet. So that's another thing that we have to extract from here that we don't have yet. So I'm just going to use identity matrix for now. And that fills that out. And now I can actually come in here and say HM terrain chunk render data, and we'll do TC data, right, is equal to the address of, and we'll do render data, shadow data, HM terrain chunks sub TG. So that's going to be kind of what we're going to write into. And then we have geometry render data. We'll just call this geo, and we're going to set that to the address of terrain geometries sub TG. Right? And now we can just kind of copy from one of those things to the other. So we can say TC data. So all this requires is index count and offset and vertex count and offset, right? So we can do index count equals geo index count, TC data index offset equals geo index buffer offset, TC data vertex count equals geo vertex count, TC data vertex offset equals geo vertex buffer offset. And that's all we need to do for terrain geometries, right? That is actually pretty straightforward stuff. And we can get rid of this guy. And that is the end of the shadow pass. So the forward pass is going to follow much of the same pattern in terms of how it works, right? So we basically just eliminate the render graph code and put up whatever else we need in here alongside that, right? So that's what we're going to do next. Let me go ahead and catch up on chats. Oh, I don't think my alerts are working because I did not hear the raid alert. So sorry about that. Apex Pixelated raided with a party of 5. Thank you so much for the raid. Welcome, raiders. I hope you guys are doing well. What did you get up to on stream? Let me give a shout out to Apex Pixelated. Stretch redeem for 250. Thank you for the stretch redeem. Ooh, my back just popped. Nice. Let's see. Are you going to support GPU-driven rendering and bindless textures? So, GPU, partially, yeah. The thing you have to keep in mind with bindless is not all hardware supports it, right? And there's not a majority enough of it that supports it that makes me want to do it. And the problem with that is that even if you do, you have to make a decision at that point. Either you don't support hardware that doesn't support it, which I think is a significant portion enough of hardware out there that I don't want to do that, or you have to write the fallback anyway. And my thought process is, if you have to write the fallback code anyway, just to use this feature, then why use the feature, right? Because then you're dealing with two branches of code, right? So as far as bindless goes, until it's adopted a little bit wider scope, I don't think I'm going to do it. It is fairly wide at the moment, but it's not unanimous, right? And so I don't necessarily want to rule things out at that level just yet. Maybe in the future, though. Do you render opaques and transparent objects in the same render pass, or each has its own render pass? They are done in the same render pass. It's just they are done opaque first, and then transparent, right? Because you have to draw the transparent over the opaque, or otherwise it gets messed up, right? And we also depth sort the transparent objects. Psycube, how's it going? You're on Windows. Yeah, I know. Welcome to the dark side. We have great things like Rad Debugger and permanent keyboard shortcut to LinkedIn here. Jeez. I'm only here because I'm forced to be. So the title of the stream kind of gives that away a little bit. My SSD, my main SSD died and took my OS with it. So this is kind of a backup streaming setup that I had, that I set up yesterday to kind of get this to work, right? I don't want to be doing this, but I lost all of my data, right? So it's going to take me a while to get that set up back up and running. So in the meantime, I'm stuck using this. Not great, but you know, it is what it is. At least it works. It's around 43% on desktops so far. That's what I mean, right? Like it's not even a majority at this point. So that's the problem, really. Is I just don't want to, I don't want to have to write 2 paths of code for everything, right? That's just annoying. Like when I switched to dynamic rendering is like, I want to say it's like 95 or 96% of desktop GPUs support it. So I was like, okay, that's enough. I can say, you know, if you're on that 4%, sorry, you know. And honestly, when we write the DirectX backend, it probably won't matter anyways, at least on Windows for the people that don't have that. But good night, your hair is looking sick today. Love it. Oh, thank you for that. Yeah. I appreciate that. Yeah, it's getting kind of long too. I don't know if you can see it, but you know, a year ago it was pretty short still. So it's almost to the point. I probably realistically have until next summer to grow it out, and then I'm going to donate it. Because that's kind of what I've done. That's what my pattern's been, is I grow it out long enough to so that I can donate it to cancer patients. And then I do that. And I cut it all off and I donate it. And you know, there's organizations that take it. Last time I did that, I was in Florida. I haven't done it since I've moved here. So I've got to find one here that is a reputable place to do it. But that's kind of what I do. Yeah, I figure, you know, it's something minor that I can do, but you know, I've done it 3 times so far. And I think though, this might wind up being the last time I can do it, because, I'm going to be 40 this year, and man, it's hot. It's very hot. And the heat is starting to have a more profound effect on me than it used to, when I was younger. So this might wind up being the last time I actually grow my hair out, but yeah, too bald and too gray. Otherwise I would love to donate it as well. I mean, that's fair enough, right? Like, thankfully I don't think I'm going to have that problem. I don't think, but, you know, I am getting some grays in here and starting to get them up here. So I think at some point that's also going to be an issue for me. I don't know about losing my hair. But yeah, at the very least, it's starting to go gray. But you know what I say to that? Like, I don't want to cover that up either, because the way that I look at that is I'm thankful to have grown old enough to start to get gray hair. So that's the way that I look at it. So I'm not going to cover that up. I'm not going to dye it. I'm not going to do any of that kind of stuff, right? Anyway. Let's see. Hi, do you have some advice on getting out of tutorial hell when working on computer graphics? Yes, I do. So what I usually tell people as far as that goes is it's the same kind of thing as learning to use Vulkan or learning to use anything else that's semi-complicated. At least with Vulkan, what I say is read the spec, even front to back, even if you don't understand all of it. Read it, then write a Vulkan renderer. Try to do as much of it as you can without having to look up any tutorials. Try to go by the spec, right? It's going to be painful. It's going to take a long time. It's going to be bug-ridden, but you'll get through it eventually, right? Do that. Get a working renderer. Don't make it all fancy. Don't worry about, you know, trying to make it, you know, super clean or fancy or reusable or any of that stuff. Just write it and get it to work, right? Because what you're going to do when you get that renderer working is you're going to take all of that code and delete it. You're going to throw it away. And you're going to repeat that process again. And you're going to start from complete scratch using none of your previous code. And you write it again. And you look at the spec for any questions you have, and you write it again. And you get it working again. And you get it to kind of where you want. And you're like, all right, delete that code, throw it out, write it again. And I know that sounds asinine, right? But the way to learn this stuff is to actually get down and do the thing, right? Repeat it. Code often, and learn from it. Do it in such a way where you're constantly learning from it. And if you do that, you will learn it much better than if you try to just follow tutorials and only tutorials without trying to also learn on your own. Tutorials can serve as a springboard, right? But you have to move on. You have to put those down and really figure out how to problem solve this stuff and work around those issues on your own. Don't use like ChatGPT or any of that kind of stuff. Basically get headaches on purpose. Yes, 100%. Because the thing I always tell people, right, and this goes true for AI too, right? People that like to use AI to write stuff. You're never going to learn it if you're outsourcing the thinking, right? So what you need to do is you need to be the one doing the problem solving, not a tutorial, not ChatGPT, not any of that stuff, right? And the more that you do that, the more you exercise that skill, the better you're going to get. So yes, it is going to be a friggin' headache, absolutely. But you're going to be so much better off in the future after you've done it a few times. There's no way around it, is what I always say. There's no way around it. You're not going to skip past it and, get around having to do it the hard way. You can only go through it. If you're actually expecting to learn it and you want to become proficient, you can't go around it. You can only go through it. Yeah. Probably not the advice you were thinking I was going to give, but, if I like doing things the easy way, I wouldn't be writing an engine from scratch either. Let's see. Mom is a nurse. When I grew up a bit, she encouraged me a lot to donate. So props to her. Not really to me. Hey, I mean, that's fair, right? Yes. And nurses are awesome. I'm married to one. So, yes, I totally agree. By the 10 times you've done it, you'll be much better than when you started. Exactly. Yep. Especially if you throw it out and start fresh every single time. It's crazy how humans work. Yep. That's how we learn best, is just actually getting in there and doing the thing. You can sit there and read theory all day long. It's not going to help you past a certain point, right? Everything worth doing isn't easy, or nothing worth of doing is easy. I think I know what you mean, McGats. Yeah. Yeah, I couldn't agree more. Yeah, I hope that helps. I hope that helps, Joel. Yeah, it is the hard way to do it, but I can guarantee you it's the better way to do it. One of the two. Yeah, exactly. OpenGL or Vulkan, and why? Loaded question. I answer this one a lot, so I'll try to keep it short. If you've never done graphics programming before, but you have a decent command of the language that you're going to be using, probably C++ or C, then I would say use OpenGL to learn the concepts of graphics programming first, right? Because the API is simpler, it's easier to get up and running. However, there's a huge caveat to that. And that caveat is OpenGL is deprecated, right? Not obsolete, there's a difference. OpenGL is deprecated. So what that means is basically that it's not going to receive any further updates. It's basically done, right? Hardware manufacturers are moving on from it. They still support it for legacy reasons, but they're not going to be adding anything to it. So the future is in learning APIs like DirectX 12, Metal, and Vulkan. Those are all explicit APIs. That's just kind of the way it's going in the future. So what I usually say is, when you're starting graphics programming, start with OpenGL to learn the basics. Once you've got the basics in terms of concept, immediately jump away from OpenGL onto one of these other APIs, because you'll need to make that jump. But if you try to learn all that stuff at once, it's going to be pretty overwhelming, I think, right? That being said, if you don't even have a good command of a language like C or C++, do that first before you touch graphics. Yeah. Hope that helps. OpenGL is dead, guys. Stop. Yeah. So, I mean, that's the thing, right? Like, so here's the thing about OpenGL, right? So it's still going to work. It's still going to work for a long time. Nobody's going to completely drop support for it because that would break tons of applications. Nobody wants to do that, right? But I think what is going to happen, and probably what is already started to happen, is there's just going to be a translation layer that happens underneath OpenGL that goes to Vulkan anyways, or DirectX or what have you. I think that's ultimately, if it's not already happening, it's going to happen. That's the way it's going to go, right? But you're missing out on features that are going to come out in these other APIs that you won't get in OpenGL, right? So again, when you're learning the basic concepts, OpenGL is fine. But you need to quickly move on from that to one of the more modern APIs. As much as it sucks, it is what it is. WebGPU might take its place as the learning API soon. Maybe, yeah. It's a little bit less shoot yourself in the foot, but still. None do WebGPU and cry due to lack of examples. Yeah, that's part of the problem with it right now, right? That's why I don't point people in that direction. Just jump in at the deep end, play with the sharks. Pretty nice, actually. Yeah, what's up? You could do that, for sure. Unfortunately, like, I learned graphics programming when DirectX 9 was new. To put that into perspective, right? So I've been using DirectX and OpenGL for quite a while, and I've always said that, actually, believe it or not, DirectX, I think, or Direct3D actually has the nicer API, but OpenGL is the simpler one, but it's got a whole bunch of legacy crap in it too. And Vulkan's going to wind up that same way. It already kind of has. WGSL is just awful. That's another reason I don't suggest people use WebGPU, because I was really excited about it. But do you still use GLSL? Have you tried Slang? I do still use GLSL for now. Yeah. I haven't tried Slang, only because I don't want to. I'm trying to do this minus adding more libraries to it. My plan is, since this engine is actually going to support multiple backends, so Vulkan is not the only thing that we're going to do. We're going to also do Direct3D and Metal, is as an educational exercise. At some point, we're going to take a look at the 3 shading languages for those. And we're going to kind of come up with our own as like an educational exercise on how you might do it, right? We're going to come up with our own bespoke language for that. That is going to translate to those languages under the hood via the backend layer. That's the goal. I don't know how far we're going to get with that, but that's kind of what I have in mind. So for now, I'm sticking with GLSL, through Vulkan, translating that to SPIR-V. Couldn't think of it. But yeah, that's kind of the plan. WebGPU would have been perfect if it supported SPIR-V, but I understood Apple didn't want to touch that peasant intermediate language. Yeah, exactly. That's the entire problem, right? Apple. Mind you, they already have Metal and Metal shading language, right? So it wasn't enough that they already have that. They also had to hook their talons into the web and push through their own standard again. It's what the internet gets for using WebKit everywhere. All right. So the next thing is the forward pass, right? So that is going to be the next thing we're going to work on. So let's do Oops. Need this. That is not what I wanted to actually do. This is what I wanted to do. Okay, so the forward pass, we're going to come down here again to our sort of old section of code. We're going to pick out what we need. So that's going to be everything in this block here. So we're going to do all of this. And we're essentially going to rework this so that it is compatible with our new renderer, right? So I'm going to cut this out of here and plop it in here. And we're essentially going to look through all of this and kind of replace these forward render graph node functions with stuff that we actually need in terms of our render data. So I can tell you right now, this forward render graph node reset, we don't need that, right? The node viewport set just sets the viewport. So we can actually do that on render data, forward data, VP is equal to, and then we can use this. Right? So we can delete that one. Then we have forward render graph node camera projection set. So what this one does, if I recall correctly, oh, it literally just sets the camera and projection matrix. Okay, I thought it extracted the matrix from these, but it doesn't. We are going to do that instead. Because we don't want to set any sort of state that has to exist in anything. We're basically just going to pass this through every frame. So we're going to do render data, forward data, and then we're going to do projection is going to be equal to current viewport projection. Now, we do have current viewport instead of world viewport here. I think we should probably switch this to use the current viewport. Instead. Wait a minute. Why is this bleating? Oh, because current viewport is pointer. All right. Okay, so we have projection and then we have camera, right? So what do we get from camera? We get render data, forward data, view. We have the view matrix and the view position. So that's going to be camera view get. And we're going to do app state current camera. And then we have render data, forward data, view position, and this is going to be camera position get, app state current camera, right? So we do all of that in the prepare frame instead of setting some state and coming back to it later. Let's see this. Okay, I forgot one minor detail here. So this pass uses a vector 4 for position. But this returns a vector 3. This is done for alignment purposes. So we actually want to extract this to a different field. So I'm going to do vec3, and I'm going to do view position is equal to, is equal to this, right? And then I'm going to do, for this one, I'm going to do, let's do vec4 from vec3. And then so we're going to do view position. And then when we're converting a vec3 to a vec4 positional, we always want 1.0. Wait, is it 1.0 or? Yeah, 1.0 for position, 0 for direction, I think. So we just want to use 1.0 for the W component there. And then that completely eliminates those calls to the render graph. Now, we do have a check here where we're saying this is only relevant if the scene is loaded. This check is already done before we even get to this pass. So we actually don't need this check anymore. So what I'm going to do is delete this, and all of this 0 setting code down here, all of that's going to go. All right. Now, in terms of skyboxes, we had talked about potentially using more than one skybox to allow us to transition from one skybox to another and be able to fade in between them. I think for this game, we're going to keep things simple and we're not going to support that. So what we're going to do is we are just going to use just a single skybox for now. So the forward render graph node sets the skybox. We don't actually need to do that. We need to do render data, forward data, skybox, right? And then we essentially need to extract these properties out of it, right? So, the SB index count equals something, right? Before we do that, though, we essentially need to grab a pointer to a skybox. So I'm just going to replace this with skybox. We're going to say SB equals, and then either the first skybox that is returned out of the skyboxes array from the scene, or 0. So just use the first one for now. Okay, I'm going to remove both of those things. So the way that this needs to work is if we have a skybox, we're going to use the skybox data, right? So if SB, and then if we don't, right? So I guess I'll just move this up here. If we don't, then we essentially need to use some sort of default data, right? We should always have a skybox, but I want to kind of set like a reasonable default for us to fall back on if we don't have that. So we'll come back to that in just a second. This needs to go come from SB, and then geometry, and then index count, right? And then render data, forward data, skybox, SB index offset, SB geometry, index buffer offset. Same is going to be true for, the vertex count, right? So SB geometry, vertex count, render data, forward data, skybox, skybox, SB vertex offset equals SB geometry vertex offset. Now we have those. The last thing we need is the skybox group and draw ID, and that, of course, the texture, right? So for this, we're going to have SB group ID, and then render data, forward data, skybox draw ID is going to be SB draw ID. And then texture is going to be the last one, SB, what is it? Cube map, I think it is. Yeah. So we have all those things. And so we'll have to figure out, kind of how we want to handle this if we don't have a skybox. Let's see. What does web GPU have to do with Apple? Apple is a huge influence in that. Huge. They're a big part of the committee. Yep. They also have a web browser. Yeah, I mean, Apple... so, for those of you who might not be aware, all Chromium-based web browsers are... Chromium itself is based off of a fork of WebKit, which is Apple's web browser renderer, which is what powers Safari, right? So yeah, it's like they're not a minor part of it. Like they own most of the internet now, because Chrome is the most is the most popular browser out there, and it's a Chromium-based browser, which is based off of a fork of WebKit, which is owned by Apple, right? So yeah, they control a pretty significant majority of how the internet is rendered. And that's actually kind of a vast understatement, if I'm honest. All right. So, what do we do in this case if we don't have a skybox, right? Do we just leave all of this empty and deal with it at the render level? I kind of say yes, right? Maybe we just don't handle this here, right? If this data isn't in the renderer, if we don't have these counts, then we just don't draw it, right? So let's go in here real quick to render frame. And we want to go, let's see, begin frame. Let's see, so here's the shadow pass. Oh, I've actually got some refactoring to do in there. I renamed some things. Okay, here's the forward pass. Okay, so we handle all the water planes. Let's see, where is... I could probably just search for skybox, quite frankly. Okay, forward pass data. Let's see, do we actually have something to handle this? This is the creation. Here's the scene pass. Okay, so render skybox. So begin render data. Okay, so here's where the shader's used. Here's where we perform all this stuff. Okay, so all of this stuff should probably be skipped if we don't have the data that we need. So actually, even though I've scoped this, I'm actually going to use that to my advantage. So I'm going to turn that into an if block, right? And say if renderer, whoa, that is not what I wanted. If render data, why is this not working? Do I not have... Oh, I have the skybox data directly. Okay. Skybox. Isn't it called skybox? Skybox data. Skybox data. There we go. So if we do not have... Let's just check vertex count, right? If we have vertex count, then we'll assume we have everything else. Assume no vertex count means no skybox. Now, in the grand scheme of things, that's probably not the way to do it. And in fact, we probably shouldn't even be uploading the geometry to the GPU to begin with. We should probably just hard code that in the shader. That's something that I should probably fix in the future. But for right now, I think that's okay. Let me put a fix me in here, I guess. In the future, don't upload vertex index data to the GPU. Just hard code it. And maybe check for lack of a texture instead here. Good enough. All right, not important enough. I have to solve it right now. Okay. Got plenty of fix me's, and that's fine. Let's see. Lumen render. Okay, so that's the skybox. Then we have scene render prepare frame. that I think we actually have to do still. For now. I think what this does is performs a bunch of debug mesh checking and other stuff. So I'm not going to worry about that for right now, but we do need to leave that in place. Pass over shadow map camera and view projection matrices, 1 per cascade. Okay, so here is where we're setting the cascade data for each individual cascade, right? So we need to do part of this, right? So we have, let's see. How do I want to set this up? I guess we need to do render data. Do we have, I don't think forward data actually has this. Cascade splits. No, it's going to be in the shadow data. We want to look at cascade count, right? And we want to go ahead and at this point, we want to do render data, forward data. Oh, actually, it's only cascade splits that we have to worry about. So we don't actually need to allocate anything. All we have to actually do is do render data, shadow data, cascade splits. Wait a minute. Not shadow data. Forward data. Cascade splits sub C is equal to that calculation right there. We don't actually need any of the other stuff, I don't believe. Render data, forward data. Directional light spaces, we do need that. Okay, so that's going to be directional light spaces sub C. And then that's going to be shadow, camera, view projections sub C, right? So we can essentially turn this function call, this function call into just that, right? Okay. So we pass over the camera view and projection matrices, 1 per cascade. Okay, so we don't have to allocate these because these are actually fixed size arrays, right? So they have a maximum of 4, right? Okay, so that is fine. Ensure the render mode is set. So that's just going to be render data, forward data, render mode is equal to that. Directional light set. Let's see. What do we need? Do we even need this in the forward? I think we actually do need this. Let's see. So render data, forward data, directional light spaces. Do we actually need? That is actually done by the material system, so we don't actually need that either. We can actually just delete that. All right, so hack. Use the skybox cube map as the radiance texture for now. All right, so we don't need this double hack stuff anymore. We don't want to support multiple skyboxes. So all we really need to do is set the radiance texture, right? So that should be render data, forward data, radiance cube map textures. And I think we're just going to set the 0 index to that. Is going to be equal to essentially this whole block of code right here. Actually, wait a minute. I can just do SB. We want to use cube map or otherwise invalid K texture. Wait, no, I probably don't want to do that. I want to do this. Okay. All right. So what we're doing here is essentially we're saying if there's a skybox, right, then we want to go ahead and use its cube map, right? Otherwise, we are going to use the default cube texture, right? Which is all we're doing here is we're just acquiring that synchronously. All right. Let me see. Let me catch up with chat here. Apotham, good to see you. How's it going? Love how your function names are big and descriptive. I hate C/go naming where sometimes things are as short as possible. Yeah, I mean, sometimes it gets to be a bit much, and sometimes I kind of reel against that a little bit. Sometimes I have to kind of abbreviate things because it gets a little bit too long. But yeah, I try to keep things descriptive so that I can keep comments kind of minimal, you know, at least where it makes sense to do so. Let's see. Forward renderer would become FWRGNODEDS. Yeah, exactly. Something along those lines. Yeah. Totally unreadable. I agree with you on that. Yep. People still running 80 character wide monitors in shambles. Yeah, I know, right? You'd think so in some cases. I mean, I only have the text this big because, well, truthfully, because there's two reasons. So you guys can see it, but also I'm blind, basically. You know, Coke bottles are getting kind of thick there. Everywhere I go is C. Just spent all day writing a game on my 8088. Oh, that's awesome. That's pretty cool. I would watch that. If you were to stream. First time chatter, welcome, by the way. Yeah, actually I have I haven't talked about this in a while. I actually have a I guess you could call it a challenge, right? And it doesn't have a time limit. If my YouTube channel ever hits 1 million subs, I'm going to basically put this aside for a bit and write a Vulkan renderer in assembly. So, yeah, that should be interesting. I don't know what flavor of assembly I'm going to use, but yeah, I've never written something like that size in assembly, but that should be interesting. All right. Been good. Opened up my game engine and said I was open up my game engine. I said I was putting on the shelf months ago. Just been working on that. Well, that's awesome. Can't argue with that. Keep it going too, you know? Make some good progress. Good luck. Kinslayer rating with a party of 1. Thank you so much for the raid. I appreciate that. Welcome. What'd you get up to on stream? Shout out to Kinslayer. Appreciate that. Give this man 1 million subs. Yeah. I realize that I'm here's the thing though. I don't think that's ever going to happen, right? I don't think it's ever going to happen, but if it does, I will stick to my word. And I'll have to be learning a lot as I go, but I will stick to my word and I will write one. I can't guarantee it's going to have, you know, all the super fancy features, but yeah. There we have it. Was making a Mad Lib generator in Python. Oh, that's interesting. That's pretty cool. I like random stuff like that. I'll tell you what, I'll toss you a follow. Thank you for the raid. I appreciate that. All right. Okay, so where was I? All right, so the next thing is frustum culling and count. Let's see. I think we actually had to disable some of this because some of it was kind of broken, but I'm leaving this code here, right? Yeah, here's where we had to disable it, right? So eventually we're going to want to actually use this, right? Now, here becomes the thing, right? So there's a couple steps we have to think about here. So there's your normal, what we're going to call the standard pass as part of the forward renderer, right? It's, rendering everything in the scene. So you render the opaque stuff, you render the transparent stuff after it. Obviously the skybox comes first. And that's all well and good. You do that through your regular, your regular view from your camera and whatnot. And it kind of renders what you would expect. However, we do have water planes to consider. And I say the plural because we do technically support plural. And I think we're actually going to use potentially multiple water planes in some of our levels. So what that means is we need to handle our rendering a little bit differently, right? So essentially we're going to have a set of passes for each one of those water planes that we're going to have to do. So for each water plane, we need to do a refraction pass, which is basically rendering the water surface as you would expect, right? Looking down to what's below the water surface, right? So we set a clipping plane where the water surface is, and we render everything below that plane and nothing above it. And then we distort it using the normal maps and DUD map that comes with the water, right? So we do that refraction pass. And then we do a reflection pass, which renders everything above that water plane. And that is used to reflect off the surface of the water, obviously, right? And then we mix those two things in the shader when we actually render the plane itself in the standard pass. So for each water pass, we're going to have to get geometry we're going to need a list of geometry to render for that refraction pass. We're going to need a list of geometry to render for the reflection pass for each water plane. And then we need a third list of geometry to render for the standard pass. Now, the good part is that we can actually reuse one of those lists a couple times. So the standard list that we're going to use is also going to work for our refraction passes because there's no camera differentiation that has to happen there, right? So we can actually use the same list of geometry there. So I can reuse that for all of the water plane refraction passes. However, with the reflection pass, what we need to do is we actually need to generate an inverted camera along the plane of the water to give us that reflection pass. So essentially what we need to do is if the camera is looking down at the water like this, we essentially need to create a camera that looks up through the water like this because that's what your reflection is essentially going to see, right? So that is going to require a separate query into the scene because the perspective of that camera is from the bottom up and is going to see different things that maybe the top down doesn't see, right? So we're going to have to actually query into the scene to get those reflection lists. We're going to have to do that once per water plane. So there's a little bit of work here that we have to do for sure. One second. Okay. So, what we're going to do is I'm actually going to rename this to, oops. We're going to call this standard view geometry count. And we're going to call this standard view geometries. Okay. And so we'll put here get a list of geometries in the standard, I should say from the standard camera perspective these get reused for the water planes reflection passes. Okay. So remember here, all that we're doing is essentially gathering lists of geometries to render, right? So what we're going to want to do is we go ahead and we grab all of this, right, which is fine. We take this, which is fine. This is the code that we're going to need to replace with our new logic. Now, excuse me, this is largely similar to what we're doing here with this geometry count business here, right? So I'm actually going to take this and we're going to go select all of this, including all of the terrain geometry stuff, because we need that too. And this as well. And terrain geometry counts, all that stuff, right? We're going to take all of this and we're going to essentially create a duplicate of it, right? And this is one of the reasons I'm saying this eventually needs to be done in the scene, because then we can make it reusable, blah, blah, blah. But for now, we're just going to kind of plug it in here where we need it, right? So we are going to get the standard pass of geometry first, which is going to be here. Let's see, we need to put this here, right? And let's see, this is also, we also have terrain geometries, terrain geometry count. Okay. So we're kind of repeating ourselves a little bit down here, but we'll get to that in a minute. Let me just mark this as sort of the old code, so that when we hit it, we know what we're dealing with. Okay. So, so we have this, right? Instead of geometry count, this is going to be standard view geometry count. And then instead of shadow data, right, this is going to be forward data. And then I think this is still called meshes, actually. Forward data, standard pass, that's what we needed. And then we'll do transparent meshes by material count, right? We need to rename that. I'll do that here in just a second after we resolve all the errors, right? So we're going to do standard pass, transparent meshes by material. And then we'll do here, this is going to be a little bit different. So this actually is not going to be a flat list anymore. We actually need a maintained list like what we have here. So this is going to be, in fact, both of these are going to be standard pass dot. And then this is going to be meshes by material counts for opaque and meshes by material for opaque. And then this, instead of being geometry render data, is going to be material render data. All right. Let's see. So, okay. So now, instead of sort of doing, well, actually, let me just do standard view geometry count. And then standard view geometries. There we go. So, kind of how we have this logic here to say if different, create a new group, and then push into the current materials array. Otherwise, if we're opaque, we don't do that. This is just going to kind of go away, right? Because this is not what we want to do here. This worked for the shadow pass. This is not going to work for this pass. So what we're actually going to want to do is we're going to want to take, let's see, we're going to want to take this whole thing right here, and we're going to want to hoist it to the main for loop body, right? And so what we'll do here is, let's see, if we probably need to switch around how this logic works a little bit, to be completely honest. So let's think about this for a second. So the first thing we do is the transparency check. But realistically, what actually matters is these, right? So the check if different should actually come first. And then inside of that, we have the else check, right? So we have one branch for transparent and one branch for opaque. Either way, we're going to have to create a new group, right? So this can actually get hoisted up here. Right, so if they're different, we have to create a new group. Then we decide here what group to actually put it in. So decide what group to add this to, right? So I guess we could just, for now, do this, right? So we'll do opaque, standard. No, that's shadow data. Oh, that's why it's so wrong. Okay, this needs to be forward data. You know what? Let me kill this for a second. Let's fix it up here first. This needs to be forward data, standard pass, transparent, materials, meshes by material rather. And then, let's see, we need forward data, transparent, meshes by material. Standard pass. There we go. Okay. So, we go ahead and we push that there. We set the current material to that. Again, we're going to have to do standard pass. Oops, not there. Forward data, standard pass. Transparent, meshes by material, subcount, right? Okay, now we can take this one, put it here, and just do the same for opaque, right? So this is going to be opaque meshes by material. This will be the same, and this will be the same, right? So we just decide which one to push it into. Now, you might ask, why don't I just take a pointer to one of these arrays, right? Because they're both the same type, right? And I could do that. But the problem is darray push can cause a reallocation that can actually reassign this array. So we don't actually want to do that because then it could wind up pointing to the wrong spot when we're done with it. So yeah, we definitely don't want to do that. Let me see. Catch up with something to do with Twitch. Thank you so much. I love the name, by the way. Thank you so much for the tier 1 sub. I really appreciate that. That support means a lot to me. Thank you very much. Don't know a lot of C at all. This project is how I'm learning. Oh, that's awesome. Certainly a fun experience. I'm glad you're enjoying it. Only just now getting ready to start a CS degree, but I've been doing Python for a while. Well, awesome. Well, good luck with that. And I'm glad that this can help in some way. So that's kind of the whole point of this, right? So I appreciate that. And thank you very much for the tier 1 sub. I really appreciate that. Let's see. We're in a recently finished Vulkan tutorial. Do you recommend going through VK Guide or jumping straight into a project? I would have at least a look through VK Guide, maybe, because that's got a different take on a lot of things. But ultimately, if you haven't done it yet, before you jump in, you need to read the Vulkan spec top to bottom. It is a lot of work. It is a lot of reading. It's dry. It's boring. I get it. But if you do that, I guarantee you won't retain it all in the first time you read it, right? But I guarantee you at some point when you're going through there and hooking things together, part of that is going to be a light bulb that goes off in your brain. You're going to go, oh yeah, I remember reading that, right? So before you jump straight into a project, I would take the time to do that. And you're going to be reading that spec a lot too. That's just a recommendation of mine. Let's see. How you came to all that knowledge. What was your learning path? I'm just beginning the Vulkan engine development 2 weeks ago in general game dev learning. Hoo boy. All right, so let me see if I can break it down a little bit. So I guess I should start all the way at the beginning, because that will put some perspective on it, I suppose. I started writing programs when I was 7 on an MS-DOS 5 machine that had QuickBasic, or otherwise known as QBasic, installed. And so I kind of like learned how to program at first on that machine all those years ago, just reading the documentation that came with it and help files that came with it. I'm completely self-taught with all this stuff. I never went to school with it, or for any of it. I don't have a degree in computer science or anything like that. I do have a degree, but it's in art. So the way that I have learned all this stuff is the hard way. I'm not going to try and glorify that in any way, shape, or form, right? But I do think I'm better off for it, and I'll tell you why. Because a lot of times when you try to take shortcuts on things, or you try to, only rely on tutorials or what people are doing now, where they sort of they outsource their thinking to, one of these AIs or, ChatGPT or whatever. They're doing themselves a disservice, essentially. So the way that I've learned all this stuff is just doing it over and over and over again over the years. When I started doing graphics programming, DirectX 9 was brand new. Just to put a little age on it, right? It was relatively new at that point. DirectX 9 was around a long time. I also did a lot of OpenGL at that time. I'm just trying to learn, my way through that. But practice and repetition, and always pushing to learn new things, and always trying to be there actually writing code instead of reading about it is the way that I learned. It takes time. There's no way around it. There's only through it, is what I always say. I'm still always learning stuff. I've learned lots of stuff while I'm writing this project that, I didn't know beforehand. And that's just the way it goes, right? You should be constantly learning. The minute that you're not learning anything, means that you're getting complacent, right? And when you're complacent, not only are you not learning, but you're also not exercising those critical thinking skills. Like a physical muscle, your brain will atrophy if you don't use it, right? So, I'm a firm believer that you should be practicing all the time. If you can, you should be writing code every single day. Reading specifications and going through documentation, reading language specifications, the Vulkan specification, all that kind of stuff is going to be the way to do it. It's not the glamorous way, but it's the right way. That stuff exists for a reason. And learning to read stuff like that and learning how to learn is the most important skill that you can have. And when I say learning how to learn, there are ways to learn and ways not to learn. And that's kind of what I talked about here briefly with, you don't want to just kind of get stuck in tutorial hell. You need to learn how to problem solve and research on your own. Try stuff, things like that. Always try new things. Never get attached to your code, your experimental code. Write a renderer, throw it out, read the spec, write a renderer, throw it out, read the spec, write a renderer, throw it out, read the spec, rinse and repeat, right? And then look at other examples as well, you know. Sometimes looking at other examples is a great example of what to do, and sometimes it's a great example of what not to do. And you can experiment with those things and find for yourself those reasons. I hope that helps. Found out you can import direct 3D resources into Vulkan by reading the spec. Yes, there is a way to do that. Yep. Still not close to finished reading it though. Yeah, I've read it 7 times now. And I still probably haven't retained a good portion of it. It's just the way it goes. But there's lots of times where I'm just like, oh yeah, wasn't there a thing with that? And then I know right where to search and spec to actually look it up. I love when non-programmers use ChatGPT to write programs. It means I get to charge them a nice fee to fix it. That's true. Job security, right? What about ChatGPT's feelings? ChatGPT doesn't have feelings. I think I may do an 8088 emulator to test my software before putting it on the hardware. Don't want to mess up the CPU with my horrible code. You know, that would be an interesting thing for you to stream. Like, I would watch that for sure, especially if there's VODs of it. That's super interesting stuff. Like, that would be awesome to actually watch. Honestly, ChatGPT helps me motivate myself to read documentation. It's a bit useful at the start. When it starts getting everything wrong, forces me to look at the documentation to fix the half-assed thing I wrote. The problem with that... Wait a minute, did we get raided? I see raid. Ah, we did get raided. Okay, it took a second to come through. My notifications aren't working, but Art Burklaus, how are you doing? Good to see you. Thank you so much for the raid. I hope you're doing well. What'd you get up to on the stream? For those of you who do not know Art, I'm going to... Let me do a shout out real quick. I can't. Here it is. There we go. So for those of you who don't know Art, he is another streamer here on Twitch who is actually writing a game from scratch in C++. He even writes his own tools and everything completely from scratch. It's pretty awesome. So if you're not subscribed to him, definitely go do that or I should say follow, because he is always doing interesting stuff on stream. And plus he always has videos of him walking around Japan up on stream, which is super interesting to watch. So yeah, that's awesome. Your notifications are also not very functional. Yeah, I wonder if it's like Streamlabs foobarring itself or something. Like, I've noticed they're not working at all tonight. But I've also had issues, like computer issues in general, so I don't know if it's just me or if it's busted. Well, someone please think of the ChatGPTs. So yeah, welcome Raiders. I suppose I should probably give a quick introduction as to what we're doing here. We were kind of in sort of almost like a just chatting Q&A mode, but what we're doing on this channel is we're working on what's called the Kohi game engine. And so this is a game engine written completely from scratch in C using Vulkan as its primary rendering backend. This is meant to be sort of a educational exercise. And so it started off as like a tutorial series. We changed formats a couple of times, just trying to figure out what works, what doesn't work. We ultimately landed on the live stream format that you see here on Twitch and YouTube. The whole idea of this is we are building a game engine from start to finish, including shipping a game on Steam. That is the goal. And we are going through all of that process, including all the pain points, the design decisions, all of that stuff completely from scratch. And the idea is this is to show a way of building a game engine. It's not necessarily the only way to build a game engine. It's not even necessarily the right way to build a game engine. We do a lot of exploration and experimentation. Sometimes we get things right. Sometimes we don't. Either way, we do a deep dive into those things either way. So the engine itself is free and open source and is available on GitHub. I'm just going to drop a link here in chat. And so the engine itself is Apache 2.0 license, which means you can use it either personally or commercially. It does not matter. All that I ask is that if you use it, you say you used it. That's literally it. As this is an educational resource, the engine itself will never be paywalled. It will always be open source and free, because I believe education should be free. And I think the more competition we have in this space, the better. Competition tends to lead to ingenuity, and that's always a good thing. So that is kind of the purpose of the project itself. So we've been, up until somewhat recently, we've been primarily working on, or exclusively working on the game engine, really. And now we've started to dip our toes into a little bit of game development code, or game code, or what we call application code in this case. We've kind of discovered various things about systems that aren't great to use, or things that need to be refactored or changed or fixed, or things like that. So the idea at this point is going to be, we're building our game, but we're going to be switching back and forth between game and engine development back and forth. We'll eventually, as time goes on, we'll probably be less focused on the engine and more focused on the game once we get all the engine issues sorted out. Because like I said, this is a brand new project. So the other things on this website are, we do have links to the source code on GitHub here. We've got a Discord server with about 1K people on it. We have links to our YouTube and Twitch, of course. I do not have any sponsors other than you guys. So I've got a Patreon link there for that if you're interested in it. There's also the stream here at the bottom of the page. That is kind of what we're working on. What we're doing right now is we're switching away from a render graph system that we had to using a bespoke application renderer, because the application itself is fully aware of the data that it has, how it needs to organize that data, transform it, and thus render it. It makes sense to, instead of having this big generic system with all of this overhead and all of these interfaces and all this other stuff, both, in terms of performance overhead and also mental overhead in terms of, maintaining that, it makes a lot more sense for us to go a little bit more specific, right? So we tried the render graph thing. That was an example of something that we tried. It was cool. We did have it working. But we're moving on from that, and we're going to something a little bit less generic, because less generic means simpler, right? Simpler to code and generally quicker. So far with what we've been working on, we've had about a 1-to-3 ratio in terms of code that we've added versus code that we've deleted. So we've deleted almost 3 times the amount of code that we've added in terms of simplifying. So that is essentially where we're at. Now, let me go ahead and catch up on chat here. What happened is I caught Art at the end of his stream, and he mentioned he would come here, so I jumped before. That makes sense. AI can significantly help in taking that first step, though. Rare AI upside. So AI can be useful in explaining concepts to you, yes, but don't ever use it for code. Don't off-source your thinking for it, right? Like, don't off-source your thinking towards it. Don't let it be your problem solver, because your problem-solving skills are going to suffer as a result, right? Thanks for the shout-out. Currently working on long-distance landscape rendering in my game for the open overworld, going very well. Awesome. Okay. I already kind of covered what I was up to, so I answered that one already indirectly. Did you ever do water simulation? No, so we don't have water simulation in here, and frankly, for the game we're making, I probably don't need it. It is something that interests me, though, and I might do it in the future, just not for the game we're working on. Let's see. Okay, catching up on the YouTube side. May I ask if Steam API and demo code will be provided in the Kohi engine? So that was one thing I forgot to mention, actually. So I mentioned that the engine is going to be free and open source. That will always be true. Jeet, hello, by the way. However, the game code itself, I am not going to open source because I actually want to put the game up on Steam and sell it, right? I'd like to make a little bit of money off the game if I can. But, I want to actually release that, right? So my plan with the game code is I'm not going to release it right away. Once the game has been out there for sale for a couple of years, then I'll probably open source it. However, I'll probably only open source the code, not the assets, right? So that's kind of the plan on that. However, what's going to come with the engine once we get to that point is I am going to essentially have a template, not only a testbed, but sort of a template game that's already set up and programmed for you to actually use with the engine. So you've got a base to actually start with. And that will be included with the engine. So while the bespoke code that we're creating here won't be included with the engine, we will be making something that will get released with the engine open source. Are all the books on the shelves programming related? No, not all of them, but let's see. Everything from basically where my head is this way is not really programming books, but everything from where my head is back towards that shelf thing is all programming books. So it's about half. I agree. LLMs are basically search engines and should be used as such. Yes, but bear in mind also that using an LLM as a search engine takes like 10 times the amount of energy or something like that than your typical Google search. So I don't even suggest using them for that. Wise man once said that AI is really terrible. Topics I know a lot about, but really good on topics I know nothing about. Yeah, fair enough. Will you donate the money to your viewers? I don't know what you mean by that. Which money do you mean? Do you mean the money I get from this? I mean, eventually, I'm not going to lie. I'd like to be able to do this full time eventually. So, but most of the time, what winds up happening is the money I get from this winds up getting reinvested into the channel, in one way or another. For example, so part of the stream title is my SSD died. So I'm actually on a backup machine setup right now. Running this stream right now because my main machine, my main SSD, just completely crapped itself yesterday. I can't get any files off of it or anything. So, yeah, that's a hardware issue that I'm gonna have to spend some money on, for example. So, yeah, a lot of times the money that I get for this does get rolled right back into it. The money from the game. Oh, yeah. I mean, if I ever made like crazy stupid amounts that I would actually not have a use for or something like that, then yeah, I would be all for doing that kind of thing. I've always wanted to like be able to fund projects for people, but like obviously I can't do that like now. But if I ever got like a stupid huge following, which I don't think is ever going to happen, but if that were to happen, I could definitely see myself doing that for sure. Posted this earlier, so I think it got skipped due to the raid. But due to my last client who used ChatGPT, I don't have to work the rest of this year. I mean, that's fair, right? Yeah, fair enough. I think I did miss that message. That does happen, unfortunately. All right. So as far as what we're doing here, this is all really just temporary code to begin with, right? This is all going to get moved to the scene once we rework the API on that. But for now, we have to do it here, which is kind of poopy, I know. But all right. So we have the standard pass, opaque meshes, and transparent meshes all sorted out by the end of this loop, right? So that's that. I just need to actually, let's see, how do I want to do? Actually, all I need to do here, so this just needs to be forward data, standard pass, and then opaque meshes by material counts is equal to forward data, standard pass, opaque meshes by material, right? So we just get the count of that. And then forward data, standard pass, transparent meshes by material. Oops. And then this needs to be forward data, standard pass, transparent meshes by material. Okay. This should be counts. Okay. All right, so we have all those counts. Each of the individual materials themselves will have the geometry count within it. So essentially what we do is we group all of these things by material and then split those things up by material category, either opaque or transparent. That allows us to keep from having to switch shader context too often, and allows us to draw the transparent geometry over the opaque geometry in a very easily not translation. What's the word I'm looking for? In a very easy to iterate list. That's not the word I'm looking for, but I can't think of the word. All right, so there's that, and then we have the terrain geometries. So terrain geometries, let's see. I feel like I don't actually need this part. Terrain geometry counts. Yeah, we already do that as well, so we can get rid of that. And then I'm actually just going to take this. Wait, what is this here? That's inside the forward pass. Okay. Oh, I see. I moved this stuff into the wrong spot, apparently. Wait a minute. Wait. Did I screw up my brackets somewhere? I probably did, moving all this code around. So that's the standard. Okay, so we need the geometry count. I can get rid of that. Take this query, put it up here. That will fix that. And then this goes here as well. Separate counter for terrain geometries. Oh, I need that up here. All right, and then here is where I set the geometries, which has been replaced by this. Okay, all right. And loaded level, I feel like I'm still, yeah, I've still got a bracket that's missing somewhere here. Because that's the end of the function right there, which should be the loaded level. But this is the end of the loaded level. So maybe I just need to delete that one. Okay. And then all of this stuff belongs inside the forward pass. So this actually needs to be bumped up to here. Okay. All right, so the next part of this is we have our water plane queries, right? So we get a count of how many water planes we have, and then we need to go through and do all of those render passes on for the water plane. So we need a reflection and a refraction pass for each one of those. And then this essentially we don't have to do, right? In fact, I'm just going to delete that. I know we don't need that. Okay, so essentially what we're going to have here is we need, let's let's see, U32W equals 0, W is less than water plane count, and then plus W. And then for each one of these, we're just going to say water plane, right? And we'll just say plane equals, let's see, I guess it's just planes sub W. And then we'll actually need to go into our render data, forward data, water plane count, and set water plane count. And then render data, forward data, water planes, which is going to be an array of water plane render datas, right? So this is going to be frame allocator, allocate, and we need size of water plane render data times water plane count, right? And again, we use that frame allocator because that is just a linear allocator that's super fast, right? So here, all we have to do is get a target plane, I guess we could say. So we'll do Illumina forward pass water plane render data, and we're going to call this WP data. And that's going to be the address of render data, forward data, water planes, sub W. Right, and now, essentially, we'll have to, we'll do to-do refraction pass data, right, and then to-do reflection pass data, right? So all this is the refraction pass is actually going to be easy because we can actually use the render list from the standard pass for that. The reflection pass, we're essentially going to have to perform a lot of this logic up here again. All right. ChatGPT code is so obvious at this point. It's unbelievable the number of people trying to pass it off as their own. Yeah, true. Is this City Escape or am I hearing things? You mean the playlist? It might have been. Let me see where I am in this. I've got a Spotify playlist going at the time. Escape from the City. Yeah, you are correct. It was. I was going to say I thought I had that in there, but there's so many songs on that playlist now that it's kind of crazy. Let's see. Have you ever considered C++ or has always been C? So I actually come from C++. I started with C++ long before I started with C. Used it for a number of years before I switched to C. But I always used what I called C++ Lite, right? So I used very C-like C++. And that's because I don't have a need for a lot of the features that C++ offers, right? There's two things that C++ offers that I would actually use on a regular basis if I were to switch to that. One would be operator overloads for like the math library, right? That's a big one. Constant expressions are another one, right? It'd be nice to have compile time string hashing, for example, like you can do in C++. But aside from that, I wouldn't really use anything else. Like I don't do, like most of this engine is not like even close to OOP, right? So I don't need all of that stuff. So yeah, I mean, if I switch to C++, it's going to be very light C++, but so far I haven't needed it. And we're looking at a close to 80,000 line of code base. So how do you create your assets like graphics and music, etc.? Do you do it yourself or outsource it? For example, I'm a software developer with artistic skills, but doing both is just huge work. So I haven't really fully decided on that yet, because I'm the same way, right? Like, I have a background in art. So, drawing, painting, sculpting, all of that stuff. And I've done lots of digital work too. I actually went to college for game art and design, which is an art degree. And so, I know that I could do it all on my own. I just haven't decided if I'm going to. Like, I've done music, I've done sound effects, I've done all those various things on my own, just making my own projects. But more than likely what I'm going to do is, especially for something like music, is I'm probably going to, that I will probably outsource. And I've actually got somebody that's already kind of interested in doing some of that for me when the time comes. So, but yeah, other than that, the only other thing that I could potentially see outsourcing is maybe rigging an animation, because I hate it. I know how to do it, but I hate it. But yeah, I hope that answers that. Will you target metal in the future or just Molten VK? And using Molten VK would be slow write, at least compared to native Vulkan or directly using metal? Loaded question. Okay, so will I target metal in the future? The answer is yes. Using Molten VK is, as far as that being slow, I haven't noticed a significant speed decrease with it so far. I'm running an M1 Mac. In fact, that's what the actual stream is running off of. OBS is running on that. And I'm capturing my other machine from it. And it runs just fine on the Mac. It runs just as fast on that, actually, as my desktop. So I haven't really had issues with that. Of course, I'm not doing anything crazy on it either. But yeah, eventually we are going to actually be targeting metal. I don't know if that's going to come around before the release of this game or not. I haven't really decided whether I'm going to tackle that then or not. I kind of am thinking probably not, and I'll just release the first game either using Molten VK or maybe not on the Mac OS at all. Haven't really decided. I'll have to see how much demand there is for it too. But I think after we're mostly feature complete, at least as far as the renderer goes, that's probably when I'll make that jump. But I won't really know that until I've shipped a game with it, right? Sonic the Hedgehog was one of my major interests. Modding those games was what got me into programming. That's awesome. I think I could try my hand at doing graphics, since you can program a lot of it, but music scares me. I have no idea what I'll do about it when my game reaches the point of actually needing art. Yeah, that's fair enough. I actually do have a little bit of a background in music too, although it's not the kind of music I would use for a video game. I used to play drums in a death metal band years ago. But, so music doesn't really scare me all that much, but like, I don't know how to write the kind of music that I would need for a game. Like, the concepts of music, yeah, I get it, but death metal does not really fit the game where we're rolling, right? So there's that. My background in art is I took one class of it in 6th grade. My art teacher basically gave a really passionate speech about how everyone is an artist. That's funny. Turned in my first project and he excused me from all the art projects due to how bad it was. That was like me learning cursive. I had a I think it was a 7th grade teacher that required every student to write in cursive, and I turned in my first paper and she's like, never do that again, just print. Spiro, unless dark metal does fit the game. I mean, it might fit certain boss battles, right? I don't have my drum set anymore though. I'll just make some procedurally generated music. What could go wrong? Yeah, how hard could it be? How bad could it be? Right? All right. Teachers that hated that I was left-handed and couldn't learn cursive for the life of me. See, okay, so that stuff's always driven me nuts, right? Like, people who are like, oh, don't use your left hand for drawing or writing. Like, what difference does it make? It makes none. Literally makes none. I used to screw with my teachers, actually, because I am ambidextrous, so I can write or draw with either hand. And I can, do a lot of stuff with either hand. It doesn't really bother me. And man, that used to piss some of them off, and it was great. It was glorious. If we can beat Windows native performance using the Wine translation layer on Linux, users probably wouldn't notice the difference between native Vulkan and Molten VK. Yeah. I actually found that to be true in a couple of cases. I had a few games that ran faster on Linux than Windows, even though it was going through DXVK, which is deeply hilarious to me. All right. So refraction pass data. Let's do that one first since it's the easiest. I'm going to go ahead and scope this for now. I don't know if I need it, but we'll see. All right. So we actually have WP data. In this, we actually have a reflection pass, right? So we have refraction and reflection. So we're going to do refraction right now. And essentially, what this one is it's going to be a copy of the standard data that we already have. That's why it's going to be simple, right? So we're going to do transparent meshes by material count is going to equal, let's see, render data, forward data, standard pass, transparent meshes by material count, right? WP data, refraction pass, transparent meshes by material. We're actually going to use the same array too, right? Because we don't need to have a separate one for that. WP data, refraction pass, opaque count, right? Render data, forward data, standard pass, opaque. And then, of course, the array as well. So there's the array. And there we go. All right, so what else do we have in here? We have the terrain stuff, right? And we actually have, let's see, we have material instance, which in this case, we actually do need the material instance stuff. There's a slight problem with that. We'll get to that in a second. So we're going to do chunk count first for the terrain. So we'll do render data, forward data, standard pass, height map, terrain, chunk count, right? WP data. And then we want the height map chunks array. And again, we can just use that same array. So there we go. So the next thing is the model matrix, which we do not have yet, right? So again, we're going to have to do render data, forward data, standard pass, HM, terrain model. Now, we can just use that here, right? And that's fine. But if you recall, when we set that further up in the above code, when we were working out the standard pass, we didn't have anything there, so it's just identity for now. And then WP data, refraction pass, HM, material instance. Now this is where it gets tricky because our terrains right now aren't fully hooked up. So we have some work to do around the materials of terrains. So what I think we're going to wind up doing, how do I want to do this? I guess I can go... Oh, wait a minute. Is this just a K handle? It's literally oh, it is the full material instance. Okay. I guess let's say material equals k handle invalid, right? And then we'll do this, and we'll say instance is invalid. Now, this is going to be a fix me. Need the actual terrain material instance here, right? But since we're not technically rendering it anyways, we're not going to have anything to render in because our chunk count's going to be 0 anyways. I'm not worried about it, right? So this is going to be our height map terrain. Also, another issue with this is only one terrain supported. We might actually want to support more than one. But for right now, it's just one. Let's see. Okay, so I think that's almost all the data we need, actually. There's a couple more things. So WP data, refraction pass. There it is, view position and view matrix, right? So view position is going to be, again, render data, forward data, standard pass, view position, WP data, refraction pass. Okay, one of my notifications just worked there, but I feel like they haven't been working half the night. What was that for? That was on the YouTube side, that's why. Thank you for the follow over on the YouTube side. Appreciate that. Can you do a brief on handles, what kind of approach you're going? Couldn't find the stream where you introduced those. Yeah, sure. Let me just finish this real quick and I will go into that. We are actually going to be changing to something slightly different too that's a little bit better. But I'll go over how this works. View matrix. Okay. So a handle is composed of 2 bits. I don't mean literal bits. I mean like 2 parts, right? So we have a handle index, which is a index into a resource array of some kind, right? So let's say, for example, you have a array of textures, and you want a reference to that texture, for example. So this would be an index into that array of textures, is what this handle would be. And then we have a unique ID, which is globally unique, which contains a 64-bit hash inside of it, essentially. And this is then matched to a matching identifier in that resource array. So each of the individual textures would also have typically something along the lines of what could be considered a generation or a matching number that this identifier goes with, right? And so the reason that you'll have that is whenever you stand up a new texture, you would essentially create a new identifier at that point. And then whenever you retrieve a handle to a texture, you would essentially copy this value into the handle, right? And the reason you want to do that is because if you release that texture and you still have a handle out there with a reference to that texture, then this unique ID will not match what is at this index within that array. That was the idea anyways. And so it's kind of like almost like a soft pointer, right? It's a way that you can kind of tell that the handle's out of date. Thank you for the sub over there on the YouTube side, by the way. Appreciate that. And so that's what the idea of handles were for. And so it works, but I'm not 100% happy with it, right? And this is another one of those things that we tried that is good in theory, but in execution is not all that great, right? So I think the idea behind this is solid. I really like it a lot, but there's a couple places where it kind of falls apart. The first of those being you have everything's a K handle, right? So how do you know what the K handle is for? How do you know what kind of resource is for? Well, you could type def that, right? Sure, that's a way around it. So there's that, but that one's kind of, you can get around that one. The one that you can't really get around, though, is this identifier has a U64 inside of it, right? Which is 8 bytes, plus another 4 bytes here, right? So each of these handles is actually kind of big, and if you have lots of handles floating around, that's a lot of memory, right? And so generally speaking, in both cases, you don't actually really need something that large, right? So for example, in the texture example, if we were to talk about using a U16 for the handle index, that's only 2 bytes, right? 16 bits. So, that's already an instant memory savings over using this structure, right? And what I've also found is that it's not really ever been necessary to track this ID, this unique ID, or generation, or any of that kind of stuff. Like we had asset generations in the past, and every time the asset was written, we upped the generation, right? But as I've simplified the APIs around the renderer and other resources that were using generation, I was able to just eliminate generation. And so having this additional check in there does kind of invoke a little bit of overhead, both in terms of storage and processing overhead, because you've got to compare them, right? And I just don't think it's worth it, right? So I think, like I said, in theory, this works. And I was playing around with the idea of a K handle 16, which basically just uses a U16 handle index and a generation as opposed to a random number, right? And I was kind of playing around with this idea. I haven't really thrown it out yet, but this is something I might wind up using potentially. And this is probably a lot better version of it, right? But if we actually take a look at the texture system itself, the texture system actually makes use of, where did I put that? The texture system actually has something called a K texture now. And that is nothing but a type def of a U16, right? So essentially all this is just a number, right? And that's the direct index into that resource array. So we still have the internal resource array in the texture system. All the texture data itself is stored within the texture system and is accessible through the API that we have here. If you need the dimensions of it or whatever. So the benefit here is instead of passing around pointers to textures all over the place, or having to pass around that huge handle, right? What we have here is just a really lightweight number that we just pass around. And that makes it a lot easier because we don't have to worry about pointers. We don't have to worry about life cycle of the pointer or any of that crap, right? We're not having to pass around massive structures full of data or pointers to those structures, which is worse, right? We can literally just use a number, essentially, but we type def it as a K texture, so it's super obvious as to what it is and where it's coming from and where it's going to. And so this has actually worked quite well, and I've been converting a lot of systems to use something similar to this, where we just type def a U16 as that, right? Because we're never going to have 65,536 textures loaded, right? It's just not going to happen. We're never going to be anywhere even close to that. And if you do get to that point, you really need to rethink your texture use, to be completely honest. So we don't have to worry about that. And the same goes with static meshes. We're never going to have that many static meshes loaded, right? We may have lots of instances of those static meshes drawn, but we're not going to have that many loaded, right? And so, this way, if we needed to bump it up to a U32 for the system, we could just change the type def also. So that's another benefit to that. But the other thing that we do is we also define these invalid K texture or invalid K static meshes, right? As invalid ID U16, right? Which is basically max U16. Right. So, in that sense, it's, what did I, there we go. So in that sense, it's much more lightweight and robust, than sort of the whole handle system. So one by one, I'm kind of just converting all of our systems to use something like this instead. So handles as far as K handles are concerned, are probably eventually going to get phased out. It's another one of those experiments that we tried. It worked well, but it has its drawbacks, right? All right. First time chatter, Jar3 Dev. How's it going? Good to see you. Thank you for the stretch redeem. I appreciate that. Curious what drew you to programming as a career choice and overall as a hobby. Oh, you were going to just suggest a handle 16. Yeah, exactly. So when I was, like I said, when I was 7 is when I kind of discovered Quick Basic. It was on my grandfather's 386, right? Monochrome screen, all that, monochrome green screen. He showed me that one day, that you could just write words in a file, and then you could essentially send it through a program, and it would make stuff happen on the screen. It was essentially how I understood it at the time. And I was like, whoa, that's really awesome. And that was sort of my first introduction to it. And I'm like, holy crap, you can write words in a file and make stuff appear on the screen and make things happen and make it do stuff. And at that point, I just became enamored with it, right? That was, it's always been fascinating to me ever since that point. It still is, right? And so that was really what kind of led me in that direction initially. And I had started as a hobby, self-taught myself how to do it. And then eventually I just kind of was like, programmers in the right field could actually make a decent amount of money. I should do this. And so I do. And the stuff that I write for work is nothing like the stuff that I write here for home, and that's okay. I've learned that separation is okay as well. The type of stuff that you have to write for a enterprise solution is not the same stuff that I would prefer to write at home, right? So I don't. So I separate those two, and I just stick with doing the code that I like to write here on stream. And that's the answer, I guess. Didn't quite follow K-texture as a number to a global texture array or something like that, GPU related resource. Okay, so oops. I keep hitting the wrong dingus keys tonight. So the texture system, if we look at how it's actually stored in here. So this is our texture system state, right? Which is sort of a global state if you think about it, right? It's global to the texture system itself, right? And we have a whole bunch of stuff in here, right? But what we mostly have is a list of arrays of fields, right? So we have a structure of arrays is how this is laid out. And the idea is so that we can quickly iterate through these things if we needed to, right? So essentially, these are the resource arrays, right? So we have an array of widths, an array of heights, an array of formats, an array of flags, various pieces of data that you would want in texture, right? So the OOP way of doing this is typically would tell you to jam all of these things singular into a structure, and then have an array of structures and index that, right? But 90% of the time, when you're doing texture operations, you really only need one or two of these fields at a time. And it's much better to just index into an array of that one thing than to pull down that entire structure into a cache line and just blow out your cache and, as you're iterating through it, right? So generally speaking, it's much better in terms of data locality to do it this way. So we have, let's see, all of these arrays here all pertain to a texture, right? So when we get a texture width for a particular K texture, which is just an index, remember, let's say it's index, 15, right? Then it literally says, I want the width for texture ID 16. And it literally goes into widths here at the 15th position, or index 15, and returns that, right? That's all it is. It's literally it. Typical 8+4 bytes issue, Zig's multi-array data structure would have been useful. They allocate each field separately, kind of like that two lists next to each other in the memory. Yeah, I mean, that's kind of like this is the other reason I kind of got away from that, right? And so the other thing we have, you were asking about GPU resources as well, is we actually are still using K handles internally. So textures are broken up into two bits, right? We have the texture system that is responsible for maintaining things like the texture state, whether it's loaded or not, what have you, keeping track of widths, heights, the format, like any of this queryable data that you would want to know for the application at the application level, right? And then it also has this handle, and this handle is a handle to a backend texture in the rendering backend, right? And that's where all the GPU resources are handled. And that has its own resource array within its state that is indexed into via this texture handles, this texture handle here. This eventually also is going to wind up being converted away from using K handles and using indexes instead. Probably even for that, it might just be numbers. I haven't really decided. Because you shouldn't be, directly talking to the renderer for texture stuff anyways. You should go through the texture system. So everything is kind of organized that way. So it's really quick lookups into an array to get the data that you need, and only the data that you need. Yeah, so I hope that helps. I hope that explains that. Let's see. Imagine doing work when you're at your free time. Yeah, no thanks. That's called being on call. No thank you. But usually don't iterate any of those over those singular fields, do you? I iterate over handles a lot, and let's see, handles, and then also states, and potentially flags. Because the other thing that I don't quite have written here yet is I am going to be adding query functionality to this, right? So I could say, give me all textures that meet this particular criteria, right? Wouldn't it be a nightmare if you remove a texture? So the way that I handle texture removal is I basically I don't actually free the memory out of the array, right? What I'll do is I'll find some way to mark it as that particular index being free. Usually what I'll do, at least what I do in the texture system, is I use the K pixel format to determine that. So if we take a look over at pixel formats, we have all of these various formats here, but we have this unknown at the top, which is 0, which is the default. So if a format at that index is 0 or the default, that means that slot or that index is free. And so all I do when I free a texture slot is I just flip that to 0, and then it's just marked as free. And then the next one I go through to actually create when I'm looking for a free slot in these arrays is I'll quickly iterate through this looking for a 0. So yeah, it works out really nicely. Still don't buy the full SOA approach. We'll see how it performs. Yeah, I mean, we'll see. But it's still, you have to admit though, it's a lot better than just passing around pointers to structs all over the place. But the beauty of this is if we were to profile this and we were to determine that the SOA approach is not great here, because I've used K texture handles the way that I have, or indexes externally, if I go to add a field to this, it becomes very easy to add a field to it. If I need to remove a field, that becomes very easy. If I decided to switch this to an array of structures, I could do that internally too. Although, again, I don't think I would want to do that. I could also selectively do it, right? So I could group all the stuff that I don't have to query all the time, or iterate in a fast loop. I could group all of that into a structure and then put that into an array. And then just the fields that I have to iterate quickly, I could leave like this. But because all of this stuff is kept internally, and it's only ever referenced by index externally, if I refactor this, I don't have to change any external code for it. You could do a classic in-place linked list of free elements. Yeah, but linked lists are like, there's a lot of indirection there, right? So I'm trying to avoid all that, right? Some grouping seems like a good idea. Yeah, and we might wind up doing that. And that won't be a very hard refactor either. I just went this way initially to see, how well it would work. Again, we try different things. This will be one of the things I'm profiling, for sure. Most of the time, though, when I'm querying stuff, it's this. So, anyway. I'm off. Thanks for the great answers. Good night. Gonna dig into your videos and streams again for sure. Appreciate that. Have a good one. I'm about to end here just in a second as well. So the back end render has its own textures, data like this. We kind of got two places where the same textures data exists. No. So the only thing that the back end actually holds is the GPU specific stuff, right? So the Vulkan specific data. So like I don't keep track of like width and height in the back end, right? There's no reason to do that. If I need to know that, I'll pass it from the front end. I keep things like the literal VK image and the VK memory that's assigned with it, right? And the VK image view, like those literal Vulkan objects, those things are what's kept in that backend array. Let's see. It'd be const time allocation though when reusing. Yeah, that's the thing, right? The allocation wouldn't be necessarily too bad, but I mean, free lists have their advantages and disadvantages just like anything else, right? We do use those in some cases here, but it's a matter of thinking about the issue and thinking about, what is actually the use case, right? So in this case, this is fine for now, but it's something that's easily refactored. All right. So with that said, it is time for me to end. I do have to get up and work in the morning. So I need to find somebody to raid. If you guys haven't already, I would greatly appreciate a follow either on the Twitch or the YouTube side. That helps me grow the channel and helps me reach more people and hopefully get more people into game engine development because we need competition in the space for sure. But yeah, thank you guys all very much for being here. I really appreciate it. And, we'll see you guys on the next stream. Let me just see if I can find somebody that's doing something somewhat related, kind of, sort of. Bear with me here a second. I think I see who I'm going to raid, but I'm just kind of double checking something real quick. Okay. We are going to raid. We're going to raid Mesaka. We're going to see what they're up to. I know they've done Vulkan programming on stream before, so we're going to see what they're up to real quick. I'm not quite sure what they're up to at the moment, but they are doing something that looks kind of interesting. So we'll see what that's all about. Thank you guys again for being here. I really appreciate the interactivity. Thank you guys on YouTube also for the interactivity. It was awesome. And I will see you guys on the next one. See ya.